Hello everyone, welcome back.
Hello.
Okay, shall we start? So before we start our multiple linear regression in R software, we'll just go into diagnostics for multiple linear regression, which is similar to our simple linear regressions diagnostics. Okay, so as you expected, the first assumption is there should be a linear relationship between x, okay, that is numerical, okay, for numerical x or explanatory variable and the response variable. Okay, so we have to look at each explanatory variable and the response variable and see if the relationship is linear or not. Okay, so we can do this by looking at the residual plots. Okay, residual plots versus the fitted value, and then we look for the random scatter around 0 or check if there is any obvious patterns. Okay, anyway, so these are the same. So the first assumption is linear relationship. The second assumption is as usual, our residual should be nearly normally distributed with mean 0. Okay, so some residual will be positive and some negative, and then we look for random scatter around the residual around 0. So usually translate for the near normal distribution of residual standard at 0. Actually, we do it with we check this assumption with the normal probability plot, okay, which we call QQ plot. And then the third assumption is as usual, constant variability of residual, also known as the homoscedasticity. Okay, basically our variability around the residual should be constant when the value of, when the x exit, when the fit value increases. And again, we can check this using residual plots, okay, which is similar to the simple linear regression. And then we have to look for the independent of residuals, okay? So residuals should be independent of each other. And basically what this means that if the residual is dependent on time series, and then we can look at the residual plot, and then that the residual would change, increase or decrease as the exit increase. Okay, so it is also, sometimes you just if you think about the data collection process, then you know that it is the independent residual or not. Okay, so anyway, we will continue looking at this in R Studio. Okay, so we have 4 assumptions, and now we will check it. We will demonstrate it using R software. Okay. Okay, so I think it is the end of theory for linear regression methods. So we will go to File Explorer, and then as usual, we will go into Drive C, and then we will open the folder exercise_SWR, and then there should be some file. Okay, actually we will be using week 3 day 3 folder, okay, which you can find it on in our Facebook group as well. So what we will do is we will copy this, and then we will paste it, simply rename it as week 3 day 5. Should be day 5. Okay, and then if I click open it, and let us move to RStudio. Okay, so I'm going to increase my font size. Okay, so far, I think we have done a lot of codes, right? But so right now what we are doing, what we will be doing is multiple linear regression. So we don't need, I mean, let us keep these line of codes, and the rest we will remove the rest. Okay, delete it. Okay, so keep it simple. But later in this, I mean, later in this course, probably next week, I will show you how we can organize the whole R script, okay, using different methods. So there are different methods. So right now, for the purpose of demonstrating, I mean, a specific topic, we will just remove the rest and then rerun it, okay? So let us run it again. So basically what we did is we clear our workspace, and then we load our necessary packages, and then we import a 3 data set. Okay, state 1, state 2, and cognitive. Okay, which and in state 1 we discussed, we use this data set in our ensemble as well as cognitive data set. Okay, so we've been looking at these separately, okay, for the multiple linear regression. Okay, so let us start with state 1. Run multiple linear regression, which we will write shorthand for state 1. Okay, so as soon as we import our data set, so this step should be followed, right? So we do it code book, states 1. Okay, so we have state variable, which contains the name of every state. Okay, so basically it is like the ID or something. Okay, in our patient ID or something. Here is the name of the state. Okay, so these are the identifier. Usually we don't analyze our identifier. Okay, so we just look at the rest, the remaining variables. Okay, from metro rest to female house. Okay, so basically you just have to check it. So there are 6 variables. Apart from the state variable, the rest are numerical variable. Okay, so we will run, we can run multiple linear regression and see, come up with the finite models. Okay, so here we only have numerical variable. Okay, we do not have categorical variable, and then we do not have any missing value so far. Okay, so why don't we try to summarize it? Okay, summarize states 1. Okay, state 1 data set. So how do we summarize it? We do this sum, and now we just simply put our data set name. Okay, which basically retrieve all the numerical variable and summarize them. Okay, so okay, okay, I will run again. So I hope you can see it. Okay, I think I better increase the font size. Okay, so anyway, so far we have already looked at this. Okay, so this is our summarization. Okay, this is our summarization, and then okay, let's take a moment and just okay. Let me run this. Okay. Okay, doesn't work. Give me a minute. Okay, anyway, let's go back to our studio. Right now, what we are going to do is we will we will spell out our response variable. We already did it the other day, but let's do that. Okay, free variable are the rest. Okay, the rest of variable a sub metro resident. A sub state. Okay, states are like the identifier, so we won't analyze it. Okay, so we can look at the poverty percent, which factors influence the poverty percentage, okay? Whether it is related to female percentage in household or high school graduate, or the percentage of white, or the percentage of people, resident living in metro area. Okay, so that is what we want to find out, okay? And then it's a good idea to say our research question, okay? Research question or questions that you would like to know. You would like to answer this. You will like this data set to answer. Okay, so what is our research question? We want to know to assess. We will simply say the predators for poverty percentage. Okay, so this is our response variable, and then the predators, the rest, will be our explanatory variable. So basically the same. Okay, it is better to write in this way. Okay, so so far we cannot go into the linear regression yet. Okay, what we have to do is we have to look at the scatter plot for each variable. Okay. Okay, so first we will look at one by one. Okay, so let's do it one by one. So what we will plot, we will make scatter plot. Okay, so we will make 4 scatter plot. Okay, so we will use with function to unspecify the data set name. Okay, and then we will say plot. Okay, so the plot function has x and y. We want to put poverty percentage at the y-axis. So we will say the first one is metro rest. Okay, and then y is poverty. Okay, and then we will look at the scatter plot. So we will just, okay, so this is our scatter plot. Okay, so next 4, what we are going to do is we will quickly copy this and then paste it 3 times. Okay, and then we will just replace this metro with white, and then with HS, correct, and female house. Okay, now we will run this. Okay, anyway, we will have 4 plots, but we already know how to create a comparison of 4 plots. Okay, we already do it. Okay, so we will set our graphical parameter to lay out 2 by 2. Okay, row. So we need 2 rows and 2 columns to put 4 plots together. Okay, so how do we do this? We will say bar. Okay, the function is bar mf row, and then we will say, okay, this will be row 2 column 2. So that's it, and then you just run these 5 lines. Okay, so there you have it. So we have our poverty versus 4 other variables. Okay, so you can quickly look at this. So there is some linear pattern, okay? And the association, I think there is weak association. And then here, there is exactly not linear because there are some outliers. So you can quickly look at these plots. Okay, and then in this high school graduate, we have a strong linear relationship, negative relationship. And then in female percentage household, we got a positive relationship, okay? The rest are negative relationship. So in that way, we can quickly check the scatter plot and then spot the outlier, okay? And then you can also, you can also look at the correlation coefficient, but we will dive into the linear regression now, okay? Linear regression. Okay, so yesterday we learned that so we have four variable, okay, four numerical explanatory variable. So according to yesterday, we have three methods, okay, three methods to select our variable, okay. So anyway, you can use either way. So we will use backward selection method, okay. Backward elimination method. So you need to spell out, okay, which method you're going to use before you use it, okay? And then we will use the, okay, adjust the R square. And at the same time, we will also look at the ENG value, okay? Okay, so we haven't talked about the ENG value, but okay, I think it is beyond this course, okay? So we will just look at how to look at the ENG value if in case you need to look at it, okay? Okay, so the first one, how do we do that, okay? So backward elimination method, if you remember, we start with the full model, okay? So we construct or simply say fit full model, okay? And then we will use the regress function, okay? Then say regress, and then our data set is state 1, and then what is our response variable? Our response variable is poverty. And then you just put every you just put 4 variable, okay? That is our full model. So we say, okay, metro, dress, and then we have white, and we have H squared, and we have female house, okay? If you, if you're going too far on the right side, then you just go down, and then say female house, okay? So be careful of the spelling mistake, otherwise you will get an error, okay? Okay, so why don't we run this? And okay, so before we do that, just remember, because we have this parameter, we ran this graph. So if we drag this down, there will be some error, but don't worry about it, okay? Some warning messages. Okay, so we have run this, so that will be our full model, okay? This is our full model. Okay, so let's read it, okay? So the output of the linear regression, the regress function from mStats package, we got 3 tables, okay? The first table is information about the linear regression. This is telling us how the model is behaving, okay? So first, we need to look at the observations, okay? So we are using all observation from our data set. So this is a good sign. And second, we look at the F value, okay? So we got high F value. And then we got the P, P is significant, okay? So our combination is working good, okay? Our combination is working well. And then we look at the R square, okay, which is basically telling us how the variability in response variable, the poverty percentage, is explained by the model. So we got 64%. Okay, and then we adjust it, okay, because we got 4 explanatory variables. So we look at the adjusted R square, so which is 61%. And then we also look at the square root of the mean square error. Okay, so this is basically the square root of this one. Okay, and anyway, don't worry about it. And also know that we have an ENG value of 280. Okay, so for ENG value, the lower the better. Okay, if you got a smaller number, you got better model. So ENG is a key information criterion. Okay, so we can use to measure to evaluate our model. Okay, the first one is adjust the R square, and the second one is ENG value, and which we can use to compare models. Okay. Okay. Anyway, if you look at this, we got four variable. Okay, and then they are sum or square. Okay, so the most the variable that contribute most to the error is the, I mean, to the residual is the sorry, to the variability is the high school graduate. Okay, so you can see that high school graduate explain a lot. Okay, and then second is the 77, which is white and then female household, I mean metro resident and then female household. Okay, anyway, so you can see we got a coefficient and p-value. Okay, so this is our first full model. Okay, so I think right now we will give this model a name. Okay, so we can say that, okay, this model is full, so we say this linear regression model full, so lm.full. Okay, and then we will run this again. Okay, so you can see that here we got the lm.full model. Okay, so I will tell you, I mean, later we will make the model comparison side by side. Okay, so this is why we are putting them into naming these outputs. Okay, anyway, and then what do? We will remove one by one. Okay, so this is step 1. Okay, step 1, we will remove one by one. Okay, so we will say regress, and then states 1, and then we say provided the same, right? And then, okay, we will just copy white to female. So we remove, what do we remove? We remove metro. Okay. Okay, so this one we remove metro. And then the same, we can do that. Okay, so we will copy that and then run it for 4 lines. Okay, and then this is just copy and paste. Okay, you can write it or you can copy and paste. So we can, so the second line we will remove the white. Okay, and then the third one we will remove the high school graduate. Okay, and at the fourth one we will remove the metro resident. But this is not a good idea. I think we will just write it. Okay. Okay, so we will remove white, and then we say, okay, we say metro res, because we want to order it so that we don't miss. I mean, I want the same order. Okay, so metro white high school graduates, and then the last one we will remove the female household, metro res. Okay, so these are all. Okay, anyway, we will run one by one. Okay, so let's run this. And then, okay, you can read this, but we will just want to look at the adjusted R square, okay, and how well it is doing. Okay, so I think let's go back and let's write this adjusted R square value, okay? Okay, here we got adjusted R square value is 0.0. And then this one, how much? We got 0.550. And next one, okay, so we got 0.601, okay, which is metro high school. Okay, so this is 0.601. And then okay, let's run this one, the dot model, which is now given as 0.387, which is low. And then the last one, okay, the last one in step 1. And this one gives us 0.618, okay? So as you, okay, you can make a glimpse. So you can see now that we got how much? Okay, so this one is the greatest, okay? And this one we got the highest just R squared. Okay, so we can also give the name, okay? So why don't we give this lm dot step 1, let's say this is model A, okay? Something like that, okay? lm dot s1a. So we will copy this, okay? Copy this and then paste it. So we don't have to write everything. So we just change it, okay? So when you are copying, when you are doing copy paste, you have to remember, don't forget to change it, okay? Okay, so again, we will run this again. Why am I doing this? Because we will do a comparison, okay? Comparison using wait, what is the comment? No. So there is a function in mStats package, okay, which you can wait here. Estimate tabulation, okay. So you can tabulate the estimate, okay, using the est tab, okay, est tabulate. Okay, so how do we use? You can just okay, you can just go to here and then tap est tabulate. So this is that. What it does is it just tabulate estimate or regression models for comparison. Okay, and then how do we use? You just put the regression model, okay, which we name here. Okay, so why don't we try that? So we will say est tab, okay, we will use the function est tab, and then we will put full model, and then we will put dot s1a, okay, and then dot s1b, lm dot s 1c, lm dot s 1d. Okay, and I think this will take a lot of space, so let us give a lot of space, and then we will run this. Okay, so as you can see that the output, I think I'm going to reduce the font size. Okay, so it is like a model comparison. Okay, so basically you can see that we are removing this M1 is our full model. Okay, so you can compare side by side. So I mean, this is a very, handy function in mStats. I think you will appreciate it. So you don't need to write this. You just run a model and then put the name of the model in the est tabulate function. Okay, so this is our first one is our full model. Second one, we remove the metro resident, and model 3 we remove the white. Model 4 we remove the what is it? The high school graduate, and then for the final model we remove the female household percentage. Okay, and then here is what is spelling out is, you can see here there is a typo error. This is the coefficient, okay, this is the slope, and then this is the standard error. Okay, and then there are asterisk, okay, which indicates the p-value. Okay, so you can read it. So if there are 3 asteroids, then P is very significant, and there is 1 asteroid, then it is 0.05. Okay, so you can look at it and compare side by side. But what we are interested in is look at this adjust R square and see. We will take the highest one. Okay, so which is in our case 0.618. Okay, so this is our goal. And then if we think about the ENG value, like I said it, okay, earlier, ENG is a key. I think it is the correct spelling. Anyway, a key information criterion, which is a different calculation, okay, of the model. This is to evaluate the model fitness. Evaluate model fitness. For model comparison. Okay. Comparison. So basically, how do we use it? The lower the better. Okay. So basically, for adjusted R square, we look at the highest number, and for ENG square, we look at the lowest number. Okay. So, I mean, these two are consistent. Okay. So the last model M5 gave us the best estimate. Anyway. Okay. Are we finished? No, we need to go into step 2. Okay. So far we only have 1. So anyway, then you can do this manually, and it is a good idea to do this manually because you can check it. You can take time and look at the result and go slowly. Okay. But in R or any other statistical software, there is an automated function. Okay. So you just press a button and it will, I mean, the best model using this method will be spit out. Okay, so there are some limitations like we already discussed yesterday. Okay, so this is using the statistics, and these stepwise are not always the best option. Okay, so because they are commonly used if you want to predict values. Okay, so if your research question is a prediction question, then you use this kind of model selection, a stepwise regression. Otherwise, it is a good idea to I mean, consult with your expert, or I mean subject matter expert, and then look at the literature of which variable we need to put. Okay, and add to the model. Okay, anyway, we will go into step 2. Okay. Okay, so our best model is to this one. Okay, removing female household. Okay, so step 2, we will also start with the full model. Okay, so our full model is basically this one, our less model. Okay, so we don't need to repeat this. Okay, we don't need to write it again. So we just copy this. Okay, and then we will remove one by one. Okay, on this tree. Okay, so first we remove this one, metro. Second, we remove white. And the third one, we remove the high school graduate. Okay, so we say that, okay, this is step 2A, this is step 2B, and step 2C. Got it? So we will compare model again. Okay, compare model. Sorry, there's S. And then we use EST tab. Okay, and then what is our full model here on step 2? This is LM step 1, right? So we will give here linear moderation. Step 1D is our best model, full model. Then LM.S2A, and then LM.S2B, and LM.S2C. Okay. Then you run this. Okay. Now let's look at the ENG value. Okay, ENG value. So the best, the best adjusted R square value is this one. Okay, so nothing is doing. Okay, so the best one is that one. Okay, look at the ENG value. The three models, the newly created three models have larger ENG value. So, okay, we will say that it is the best model. Okay, so the best model is removing the female household. This one. Okay, it is the final model. Okay, anyway, so we got a final model and then we will check the assumption. Okay, so we will check assumption. So you just run that again, then the model again. Okay, I think you just copy this. Okay. Okay, so what is the difference if we just run the name? Okay, what will happen if we just run this name? Okay, so let's look at this. So this is the output from the regress function. Okay, so if you run this, you will get you will come up with 4 output. Okay, 4 output. So 3 table plus original model. Okay, this is our original model. So basically what it means that we can use the name, I mean this name to further process whatever you need to do it, okay, with the original model, because the output is also connect the original model. And also these table can also be further processed. Okay, so that is the idea. Okay, in order to get the this kind of output, you need to run this again, okay? Because we are going to look at the plots, okay? Okay, so we will say that plot is equal to true, okay? And see if what kind of plots we will come up with. Okay, so let us look these plots. Okay, so anyway, I think it is, so first look at this residual plot, okay? These are quite, randomly scattered around 0, okay? So we can say that, okay, linear assumption as well as the constant variable assumptions are met, okay? And then we got the normality a little bit, skew from the normal, right? Okay, so normality is not quite satisfying, okay? So we may need to think of something, but I think that is not that severe, okay, slightly skew. Anyway, let's look at this one, okay? So this is the Cook distance. So we may have some, okay, we may have some one observation which is outside the Cook distance, okay? This can give us some problem, okay? But anyway, so this is how you run the multiple linear regression to get the final model, okay? Okay, time is, the first session is almost up, so we will just stop here now and then rejoin the meeting, okay? Okay, so any question at this point? Okay, so let us continue with our other models, okay? Other data set. Okay, So what I will do is I will because as you look at this here, we got several other models. Okay, so which it is not a good idea. So we will clear this up. Okay. So you can manually remove the model you save. Okay, model you save. So like we can say that, okay, lm full lm dot s1, you can do that. Okay, but I think let us spend some time, and I mean, let us give us some time, and then we will just do this. Okay, so what do? We will do ls. Okay, which is the same as rm list equal to ls. Okay, so we use the ls function, which is to list everything under this global environment. Okay, so you're going to see that we got several other things. Okay, so anyway, we will just we will turn off the graph. Okay, turn off the graphs because it will give us a warning every time we the margins are too large. Okay, something like that. So we will turn it off. Okay, and then clear this console. So press Control L, and then we will list. Okay, we will list it. So I'm going to teach something how to retrieve. I mean, how to find. So what we got here is the model names. Okay, with let's start with lm dot. Okay, so we will find. Okay, so when we do ls, we got the list. Okay, we got a list, and we will say, okay, if this list contain the character lm dot, then we will remove them. Okay, so how do we do that? We will do that using grep. Okay, so which is a pattern matching and replacement. I think this is a little bit advanced, but I think you will get the idea. Okay, so how basically you specifying the pattern. Okay, the pattern here is lm dot. Okay, so we have the model name with the name starting with lm dot. So we will say, okay, the pattern is lm dot. Okay, and then we put ls. I think I guess you get what I'm saying. Okay, so our pattern here is lm dot. Okay, which we name our model, and then next is our x is ls. Okay, so we will run this, and it will give us a value. Okay, which is a integer position of the ls. Okay, so say the position that contains ln dot are 2, right? 2, 3, 4, 5, 6, 7, 8, 9. Okay, up to 9, right? But we don't want this number. What do we want is the value. Okay, so we will say that, okay, the value true. Okay, so when we run this, we will get the name of the model. Okay, okay, so that is our name of the model that we want to remove. So we will say that, okay, remove, and then we will paste this comment. Okay, so remove our model, name of our model. Okay, so we'll, oh wait, Wait a minute. Okay, give me a minute. Okay. This should work, right? I don't know why it doesn't work. Okay, why don't we try this? Remove say the text. Okay. It's not removing. Okay. Okay. It didn't work. It should have worked, but we are not going to think about it. Okay, so I think we will do this. We'll just do this. State 1, state 2, wait, state 2, and then cognitive. Okay. Okay. So another way to do, I mean, you can just clear this and run the first 3 line here, but it's not ideal because we want our R script, okay, run line by line. Okay, so we don't want to go up and down to run specific line. Okay, it's not a good idea. We want to go from 1 to 94 line by line. Okay, so what we do is, okay, we want to keep these three object here, and apart from these 3 objects, we want to remove everything. Okay, so basically we want to get the names of the object that is not in this list. Okay, so basically we have this. Okay, and then we will say, okay, we will remove this one. Actually, this is the same as doing what I have just did, but I don't know why that didn't work. And this also didn't work. Okay. Okay, I think we need to specify list is equal to. Maybe that's why. Oh yes. Okay, that's why it didn't work. Okay. Okay. So I think this one also should work. Okay. lm dot and then we will say that, okay, value is equal to true. Okay, so I'm going to run everything again and trying to demonstrate. Okay, so trying to demonstrate this line. Okay, it should work because so you need to put the list is equal to, okay, this equal, and then you do this, and then if you focus here, and when I run this, only these 3 remains. Okay, so that is also basically an idea of how we name these results. So, okay, so that we can quickly remove them when we need to. Okay, so these two line works the same. Okay, so basically I'm going to okay, keep this and move on. Okay, move on to state 2. So the next data set, so we will add a session by pressing Control Shift R and say that, okay, analysis for states 2 data set. Okay, so I think here it is also the same. First, we need to look at the code book. Okay, so this one is also ideal, right? So because we got a categorical variable. Okay, so we will, I mean, I will show you how to do that for state 2. Okay, and then for cognitive, you try it yourself. Okay, and then probably you look at, you just tell me what is your conclusion of the cognitive. Okay, anyway, we'll start by summarizing. Okay, summary statistics, summary measures for state 2 data set. Okay, okay, so before we go on, we will just say our research question. Okay, what is our research question? Our research question is, we want to find out, to assess, okay, whatever you use, to assess the predators for the SAT. Okay, that is the goal for the linear regression, because we are looking at the association, not the prediction. Okay, so our research question is the association problem, not the prediction problem. Okay, but anyway, you can predict the same. Okay, the steps are the same. So the prediction is the next step. So this is the first step, and we will get the association answer. So how to do the summary measure? You just sum, okay, sum and put the whole data set. And then you can see that region also summarized using numerical measure, right? This is not a good idea because we want to keep region as the categorical variable. Okay, so we will change that, but in a moment later. Okay, so right now we already discussed this. Okay, so you just look at that. You just look at these values. Okay. Now, okay, and now we will change. Okay, convert region to corridor version. Okay, corridor version of region. So how to convert it? So we will use states to, I think we will use the piping function, and then we place region, because I've shown this the other day. Okay, on day 3, I've shown this how to do that. So this is the corridor version. So we say that as dot corridor and then region. Okay, and then we will save this as back to state 2. Okay, so we have to assign it back to state 2. So this is how you really do it. Okay, the other day we didn't save it. Okay, we just look at the result. Okay, so now our 51 observation has been replaced with a corridor version. Okay, and now we will continue with our summary measure, which is we will tabulate a region. Okay, so we tab state 2 and then region. Now we will see that we got 1, 2, 3, 4, which is one observation is missing. And again, we will also look at the look at the plots. Okay, with several plots. Okay, so we will mention state 2, and then we will plot it. So the variable is region. Okay, and then the response variable, which is y, is the C set. Okay, so basically this will produce, I am guessing. Okay, this will produce as the box plot. Okay, which we haven't discussed. Oh no, this is not box plot. Okay. I think this just gave us the numerical measures. I think the plot function converted back to numerical version. Okay, so one way to do is this: we can just put it as a factor and then region. Okay, I think we won't explain it what factor is. Okay, but consider this is the categorical. Okay, but a special case of the categorical data type in R. Okay, so by doing that, you don't need to do that for every function, but for something like plot, you need to do that if you have the numerical number, I mean the corridor version or numerical number. Okay, so this is I think this is a new thing, okay, for you. This is called a pause plot comparison. Okay, pause plot comparison, which is a very good, a nice picture. So you can see the trend, right? So the trend is not linear here. Okay, so it went down in 2 and then up again in region 2 and 3 and 4. Okay, so anyway, there is no the trend among this category. Anyway, so we can use factor to transform it as a, to indicate as a categorical variable. Okay, to come up with this pause block. Anyway, it is the same result as the using the simple, I mean without factor, right, which we have already seen. This is also the same, right? So you can see the trend. Anyway, next we will look at several plots. Okay, so I think we have how many observations? Okay, so you just replace it with the name. Okay, so region, we have finished region, so percentage. Okay, so we will do with the first 4. Okay, we will do it for variable. Okay, otherwise it will take a lot of time. So we will take percentage. Okay, percentage, and then we will take expense, and we will take income. That's it. Okay, for the demonstration. So this will give us the scatter plot. Okay, so let's run one by one. So this is the percentage. You can see the clear, I mean clear trend, but exactly this is, you can see that this is not exactly linear, right? This is not exactly linear. So if that is the case, what you can do is you can copy that and then exploit it. Okay, transform it to log scale. Okay, so as you can see that it is the log scale of percentage, which will give us a linear relationship. Okay, so you can do that if your data is not, I mean, if the scatter plot does not show a linear trend. Okay. Okay, so this is one, I mean, this is one application that we use from our discussion. And then we look at the A spans, which is also not exactly linear, right? So you can also do the same. So copy that, and then we can log it. Okay? Anyway, this will transform a little bit, okay? But you need to be very careful when you interpret the result. If you're going to use this log scale on the linear model, okay? Then you have to interpret it on a logarithmic scale, okay? Which is a little bit difficult to understand. But anyway, this will give us our, this will solve our nonlinearity problem, okay? Nonlinear problem. So anyway, these we can transform, log transform all these. Okay. So anyway, we have plotted this scatterplot. So we were just going with our linear regression, multiple linear regression. Actually, you should do with a simple linear regression, but based on which methods you use. Okay. So let's use the forward elimination method. Forward method. Okay. And we will use p-value. Okay. We will use p-value in this case. So actually, this is called a model selection. Okay, so based on the limitation of time, we just dive into model selection method. Actually, before you do that, you have to explore. I mean, you have to do simple linear regression first and look at the result one by one. Okay, take your time and familiarize yourself with the, I mean, with the data set you're with. But we just want to dive in for the sake of time. Okay. Okay, so forward method, how do we use that? So we come up with one variable, okay? So step 1, we have one variable, okay? So we say regress, and then we say states2, and then our response variable is C set and region. Okay. Actually, we were used for four variable: region, percent, expand, and income. Okay. So we will write another tree, duplicate another tree line, and then say percent and say income, no, expense, then what income. Okay, so you can look at one by one, or we can just give the name. Okay, step 1A, step 1A, and then we will be lazy, and we will copy this and paste this. Okay, so now we will compare models with the E-step function. Okay, E-step estimate tabulation. Okay, so lm dot. Okay, we can just copy paste here, comma, copy paste here, comma, paste here, C, paste here, D. Let's run this all together. Okay, so now you can use p-value, right? So actually all using p-value, everything is significant. Okay, so trees are significant. So you remove the, okay, so anyway, we have to keep everything. So the next step would be putting second variable. Okay, so you can choose one and then continue. Okay, because all are significant. Using p-value. Okay, so how do we come up with a p-value? We look at the asterisk star, okay, which indicate the p-value. Okay, so we got 3 in CSAT. Why CSAT is there? Okay, no. Okay, for the expand 3, for the income 3, for the percentage 3, region also significant. So you can just start with one. Okay, so step 2, we will add. Okay, we will copy this and add another 2. Okay, so region, what do we add? Percent. Okay, and then expand, then income. Okay, and this will be 2. Actually, I think we should 2B and 2C. Okay, and then ESD depth. So at this point, we do not need to do this. We do not need to take the full model because this is not backward elimination. Okay, this is forward elimination. So we can just compare these 3 models. Okay, and then we say C, and then there is B. Okay, so this will save a lot of time. And then you compare the p-value. Okay, so the first one we add percentage. Okay, both are significant, and second still significant, and that one income also significant, region also significant. Okay, so still it is valid. Okay, so next step 3. Okay, you take one. Okay, whatever you take one. Okay, it's a good idea to take the first model, which is highest percentage anyway. So this will be our model tree. Okay, so essentially this is how you do it. How you do this. But and then you add the, what do you add? Expense, and then you add the income. Okay, I think that's it. So when you have gone higher step, then you will be dealing with lower variable. Okay, to add, and then we will compare again. Okay, lm.s3a and lm.s3b. So we'll run this. Okay, and then you look at the p-value. Okay, so look at the p-value, and then So see here, A-span does not give you a significant result. Okay, so you didn't, this one we don't want it. Okay, then income, we got p-value significant, percentage significant, region also significant. So that the last one will be our final model. Okay, so our final model is region plus percentage plus income. So if you look at the ENG value, this last model, model 2, this last model is lower than the first model, okay? So which is clearly better. And if you look at the adjusted value, it explains 85%, okay? So we will say that this is the final model, and then you look at the assumption, okay? Assumption for MLR. Okay, so which is basically you copy this one, and then you give it a plot is equal to true argument, okay, and then run this. Okay, so we got a standard graphic is not okay. Anyway, when you look at this, there is some, I mean, a little bit cluster here, a little bit cluster here, okay, not exactly constant. So you need to be very careful how to deal with it, because we have already seen it, right, in a scatter plot above, that they are not, some variables are not exactly showing linear regression, linear relationship. So you may think of looking at the logarithmic transformation. Okay, so okay, anyway, these are not showing linear transform, and okay, anyway, this residuals are showing normal, so the normal is correct. Okay, so we need to change that. Okay, so there is no inferential points here, so we need to, okay, log transform. I think we will log transform everything except region. Okay, and look at the plot. So how do we do this? We just write log, okay, percentage, and then we will say log income. Okay, this is how you do it. I hope it works. Yeah, it works. So you can see that it is now quite quite doing okay, right? So linearity assumption is okay, constant variability assumption is okay, and no inferential out points, and then normality is a little bit off from a dotted line, but I guess we are still okay because we have a 51 observation anyway. Okay, so I think this is how you do a multiple linear regression. Okay, so we got a lot of lines, I mean R script, and probably this week or next week I will show you how to organize, I mean how you should organize your R script. Okay, so basically this is how you do it. Okay, and even so, what you can do is you can also put this one into the A cell. Okay, I mean any regression output you can export it into A cell. Okay, let's try this. Okay, because we have some time left. This is the end of the linear regression. Okay, so we still left with the cognitive function. So try that. Okay, try that on your own, and probably okay. Why don't we do this? You try it on your own, and when I post the today's video on our Facebook group, you comment it with the best model that you come with. Okay, so what is the best model? You write, okay, the final model is what, and what. Okay, so the first one you need to write is your final model. Okay, and then which method do you use? Okay, do you use forward or backward, or you just use your logics? Okay, you just use your thinking. Okay, so you need to write a final model and which method to use. Okay, I think that is the homework. Okay, anyway, I mean it's not serious. So if you have time and you can, if you have done it, then you write, I mean, comment it, okay? And we will see. And probably you also say, what is your adjusted R square, okay? Or if you, I mean, if you use p-value, then it doesn't matter, okay? So I will show you how to export these results, these linear regression output, okay? Linear regression output to Excel. Output to Excel. Okay, so there is a function called export, okay? mStat. So basically you just, I mean, you just export whatever you want, okay? You can export a lot of things. Okay, what can you export? Okay, first, you can export outputs, I mean, result from tabulations, I mean, summary measure, okay? So I will quickly demonstrate it for you, okay? But to do this, you need to assign it to some value, okay? Some names. Okay, so why don't we do this? We will summarize state 1. Okay, in fact, summarizes state 2. Okay, state 2 is much better. Okay. Okay, this is our summarization, and we will say that, okay, this is the sum 1. Okay, we will name it as a sum 1. Okay, and then we run it. Okay, so when you print it out, when you run this sum 1, you will see there is a table. Okay, so we want to export this table so that we can just copy and paste and for our final manuscript. Okay, and the same we can also tabulate. Okay, so we will say tab 1. Okay, and tabulate states. Actually, when you tabulate, you only have the region. Okay, the region is the only one. And when you try to run this, okay, you will get the result. Okay, this one. This is exactly the table. Okay, so how do we export this? So you say export. Okay, so there are two arguments that you need to make this function work. Okay, the first one is what do you want to export? Okay, so one by one. Okay, you have to do it one by one. Okay, first one we will export it is the sum. Okay, and then we will export it. Okay, so what is the file? Okay, so you need to mention name of the file. Okay, so we will say that, okay, this is the testing output export function. Okay, so we say that test export.csv. So you can, I mean, it's a good idea to save it to CSV. Okay, you can only save it to CSV anyway. Okay, the reason is when you do the code book again here, because we change it to the character version, remember? That is the reason. That's why you need to code it every time, okay? Because we change it to the character version, so when we submit, region is left out, okay? And then when we tabulate it, tabulation only take the character variable, okay? Variable that is shown as a character or some other things. Here the character, that's one. But if you want to specifically tabulate other variable, then you can mention it. Okay, you can mention, okay, we want region, and then what do we want? We want expanse, something like this. Okay, and then when you tabulate it, it will give you. So this is like explicitly mentioning the variable. Okay. Otherwise, you can just leave it and make the tabulation function do it for you automatically. So when they do it automatically, it will just take the character, the variable that is shown as a character data type in output and tabulate it. Okay, that's why. That's the reason. Okay, so we need to do it twice. So the first time you export it, you just write it. Okay. The second time you export it, I mean, we need to export it one by one. Okay, so we export someone, and then we export that one. Okay, but here we need to append it. Okay, so we need to mention we want to append mean combine. Okay, combine this result to that result in the test export. Okay, so this is how you export it. Okay, so let us run and see. So this should appear in our export SSI underscore SWR folder and a drive C. Okay. Okay, so save as this one and also append it as this one. Okay, so let us go to the this one. Okay, and now you see there is a text export .csv appear. Okay, so you can double click it to open with the Microsoft Excel. Okay, so as you can see, you can manipulate here. Okay, you can copy paste, you can change this as you like, you can do whatever you want. This is how you export it to Microsoft Excel. Okay, so let us go back to RStudio, and then I will show you how to export this table. Okay, this one. Okay, why don't we try this one? Okay, it's a little bit bigger. Okay, let us run this again. So we will have this table. Actually, you don't have to assign it, you can just directly export it. Okay, but it is a good idea to assign it first. Okay, so this one is the coefficient 1. Okay, say the coefficient 1 because these are the coefficient, and then we will export to the same data set and append it. Okay, combine it, not going to override it. So we will say coefficient 1. Okay, and then run this. Okay, now it is exported. Okay, but when you export it, you should not open, I mean, you cannot open this CSV at the same time you are appending. Okay, so when it is appended and this file is open, it will fail. So you need to understand it. Okay, so now we have this this one. Okay, actually some other papers they report this kind of table when they write, I mean when they publish their paper. Okay, so this is one way you can consider. Okay, so you will say that okay, we want the actual linear model. Okay, so you can also do the same. Okay, save it to assign to the object and then export it. So this is how you do it, how you use export function. Okay, so you can read the mStats guidebook and it is all written there. Okay, so you can follow that. I think time is up, so if you have any question, just message me or post a comment on Facebook. And okay, if you have time, then do the homework, okay, for the cognitive one. If not, it's okay. Okay, so tomorrow, we will see you tomorrow. Okay, so good night.